Moving on here, we've got some more examples. Again, we're working with only real numbers. Using complex numbers, we can get negative numbers, but if we're only working with real numbers, remember, what this means is what number times itself gives us negative 4. Now, if we assume that this number is positive, so plus x times plus x, that would give us a positive x squared. If we assume that it was negative, negative x times negative x, well, a negative times a negative is still a positive x squared. But since what we have on the inside here is negative 4, there is nothing, neither positive nor negative number that will work. So in this case, anytime we have the square root, again, if it's an even number, this one being 2, this is the square root of a negative number, we would say that there's no real solution. Again, in 5.9, we'll look at complex solutions, but in this case, as long as we're looking at real numbers, there's no real solution. Moving on to E, here we have square root of 1 over 9. Now, in this case, we do have a property that says we can basically kind of split up our radical between the numerator and the denominator. So we would have a radical 1 over radical 9, or square root of 1 over the square root of 9, which square root of 1 we know is 1, and the square root of 9 we know is 3. And because there was no sign in the front, we know that is just 1 over 3. So we are finished there. Looking at again at this third example, same thing, we can split it up to cubic root of 1 over cubic root, that's a root of 64. Sorry if that looks like a 9, that's a 64. Cubic root of 1 is 1. Cubic root of 64, well, we refer back to our chart. We look at n to the third, go down and we find 64. That coincides with 4. So this is going to be 1/4, 1 over 4. And if we wanted to check that, we would say that 1 over 4 times 1 over 4 times 1 over 4, that's the same as 1 over 4 cubed, equals 1 over 64. So this checks out, and 1/4 is our answer. Moving right along, we've got G here, square root of 4/9. Same thing, we break it up into, oops, kind of jumped the gun there. Radical 4, or square root of 4, over square root of 9. Which again, we then can break down even further. Square root of 4 is 2. Square root of 9 is 3. So we're left with 2/3. Again, if we want to check that, remember this is a square function, or kind of the inverse of squaring. So we would say that 2/3 squared is what we're looking for. 2/3 squared is 2/3 times 2/3. And 2/3 times 2/3 equals, well, in multiplying fractions, you go straight across. 2 times 2 is 4. 3 times 3 is 9. 4/9, which is what we started with to begin with. So 2/3 is our answer. Coming back to example H here, cubic root of 8 over 27. Similarly, we can split that up into cubic root of 8 over cubic root of 27. Referring to our chart, we'll see that n cubed, when we're looking for 8, our n would be 2. So cubic root of 8 is 2. Cubic root of 27 is 3. So again, our answer is going to be 2/3, just like in G. Again, if we want to check that, we'd say 2/3 times 2/3 times 2/3, which is same as saying 2/3 cubed. 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. And 8/27 is what we started with. So we know that that one is also correct. I is going to be similar to, which one was that before it? D, I is similar to D in the fact that we have a negative under our square root function. So in this case, anytime you have a odd or an even number here, so if it was a square root like 2, or say it was a fourth root or a sixth root or an eighth root, we say that it's no solution, or no, pardon me, not that it's no solution, it's that there's no real solution. You really want to make sure that you are clear on the fact that there's no real solution, because in 5.9 we'll see that there is a complex solution. Now I told you that I would show you how that odd function works. Let's say if we had cubic root of negative 27. So in this case there is a negative that we're working with, but we're working with an odd number root. So this is a cubic. Well, we'll look at just the 27. We notice that 27, and we're looking for the cubic, 27 is 3 cubed. But since we're working with a negative 27, we would say in this case that it would be negative 3 cubed. And how we check that is we have negative 3 times negative, oops, lost my times there, times negative 3 times negative 3. If we just look at our first two here, negative 3 times negative 3 is positive 9. Now a positive 9 times a negative 3, positive times a negative is negative. 3 times 9 is 27. So in the end, we have a negative that we're looking for. So anytime that you have a negative under the radical, here's our radical, and underneath it is a negative, the root that you're looking at has to be odd. If it's not odd, if it is even, then there's going to be no solution. If it's odd, then there can be a real solution. Let's go on to the next ones here. Simplify using the absolute value. These ones should be fairly quick. If we look at, we have a sixth root of t to the sixth. Anytime that you have the roots on the outside, that'd be the same as saying, so let's say we have like a square root, that's a 2, sorry, square root of x squared. That would be the same as if we were to say x times 2 over 2. This 2 here is basically the one we have on top. This one becomes our bottom one. So in this case, 2 over 2 would be 1. So we'd be left with x to the 1 or just x. So the square root of x squared is just x. Similarly, looking at example A, the sixth root of t to the 6, we could rewrite as t to the, we have this 6 here, that would be going on top, and this 6 here should be on bottom. So the sixth root, or it'd just be t to the power of 6 over 6, which is the same as t to the 1, which is just t. So that would be our first example. Looking at this second example here, similarly we have the fifth root of 243 times x plus 2 to the 15th power. Now again, we're looking for the fifth root of things, so we can notice that 243 is 3 to the 5th power. And our x plus 2 to the 15th power, we can break that down into x plus 2 to the 3rd power, that to the 5th power. Because still our 3, or our to the 3rd power to the 5th power, power to power, or exponent to exponent means multiply. So our 3 times 5 would be to the 15th. Now all of that is under the 5th radical. So we look at it as such. Now again, 5 and 5, and our 5 here leaves us with 3 times x plus 2 to the third power. And so in this case, this is our final answer. And that's everything we have for 5.5.